The purpose of this video is to go over some questions in Chapter 5, and a lot of these covered the same concept. And to save time, I've already kind of done the calculations. So this first one, the following table lists the probability distributions of a discrete random variable, and you're asked to find the mean and the standard deviation. Looking in 5.3, you're given the formula for the mean and the formula for the standard deviation. So you take the sum of all the x values times the probability of x happening, and you add that up together. So if I go to Excel, I've done that. I was giving x, and I was given the probability of x. So I took x times the probability of x, and I add that all together, and I got the mean, which is 4.08. Standard deviation is found by taking the sum of x squared times the probability minus the mean squared, and then taking the square root of that. So calculating x squared in Excel, I did that, and then I took x squared times the probability, and I added that together. So then I take the square root of 19.08 minus 4.08 squared, and I take the square root of that, and I get the standard deviation. So those are just kind of some examples of how it's done. The calculations, Excel gave me a shortcut, so I don't have to plug it in my calculator. The next question is an example of binomial formula. Again, I used the Excel to make the calculations a little easier. 30% of law students who set for the bar exam pass the first time. So the probability you pass is 30%. The probability you fail would then be 70%. We want to find a random sample of 15 law students. We want to find at most 3 will pass. So I need to find the probability 0 plus the probability 1 plus the probability 2 plus the probability of 3. Binomial formula can be calculated this way. This is the combination formula. A lot of your calculators have a combination button. If not, you can use Excel or an online calculator for combinations, or you can do the longhand. Total number of trials, probability of success, probability of failure, number of successes in that trial, number of successes in trials, and number of failure in trials. So again, the probability 0, that means 0 pass, 15 fail, 1 pass, 14 fail, 2 pass, 13 fail. So I would do combination of 15 choose 0 times 0.3 to the 0 power times 0.7 to the 15th power. That's how I got this number. Combination of 15 choose 1, right, because I'm going to pick times 0.3 to the first power times 0.7 to the 14th power. Combination of 15 choose 2, 0.3 squared, 0.7, 13. Combination of 15 choose 3 would be 0.3 cubed times 0.7 to the 12th power. Those 4 numbers added together will give you the probability at most 3 will pass. So that's just applying the binomial formula, doing it X amount of times, depending on if it says at most 4 will pass, then you would have to do the next one, probability that 4 pass, and add them together. 5.4 is an example of binomial distribution. So the probability is 0.65 that don't have cavities. So then you can get the probability that they do have cavities by taking 1 minus that. Q would be 0.35. And N here is 71. So the mean is very easy. You take the probability of the larger sample times your sample space. So in this case, 0.65 times 71. And that will give me 0.65 times 71 will give me the 46.15. So that's going to be your mean. Your standard deviation is going to be your square root of n times p times q. So 71 times 0.65 times 0.35, then take the square root of that. And that gives you your standard deviation. Number 62 was pretty straightforward. You're using Poisson probability distribution formula. So you're going to plug this into your calculator. Lambda is going to be the mean number of occurrences, and E is the constant 2.71825. Most of your calculators have an E button. So on this one, we're taking 4.5 to the 5th power times E to the minus 4.5 power divided by 5 factorial. Plug that in, you should get 0.17083, round 4 decimal places, and you get the answer. So that's just plugging in that formula. The next question is very similar to the law student question, except we're using the Poisson probability distribution formula. So the average number of defective bolts in this case is lambda, which is 4. And then depending on what it's asking, we want to find exactly 3 defective. So here x is going to be 3, lambda is going to be 4. Plug that into the Poisson distribution and you get so I did this in Excel and I did a couple different ones. So if I plug in, I can edit it. So here, lambda being 3, and you can see it is that answer. I just use this formula. If I change it to lambda being 4, it calculates it for me, and I can put it for the probability that lambda is 4, and I can just put it there. Probability lambda is 3, 2, 1. This would be the formula in Excel that does my calculations for lambda and x. You can also hold that in your calculator. Doing problems like this would be 0.1954. Here we're going to have to do at most 5, so we need to do the probability of 0 plus the probability of 1 plus the probability of 2 and so forth. So you can see I did that here and I added those up and I got that answer. So these are a little tedious. If you have Excel, that can work out well. You can also see this table in Appendix B. And it gives you that printout, so you don't have to necessarily calculate it, but you should be able to. If you have any other questions, please keep me posted.